Hello, welcome to Infinity Prep. In today's video, we'll be covering solving equations and inequalities. You will be required to solve equations with variables on both sides in both algebra and higher level math. And to solve these types of questions, you need to remember two things. Any operation done to the expression on one side of the equal sign must be done to the other side as well. And to solve for a variable x, you need to isolate it. Let's take a look at an example to demonstrate what I just said. The question states, solve for x when 3x plus 4 equals 8x minus 11. In this equation, there's an x term on both sides of the equal sign, but our goal is to have only one x term alone on one side of the equation. We first need to remove 4 from the left side of the equation, and to do this, we need to subtract 4 from the left side. But what you do to one side must be done to the other, so we also subtract 4 from the other side. And when you do this, you get 3x equals 8x minus 15. The next step is to move 8x from the right side of the equation to the left. And to do this, we have to subtract 8x on both sides. The equation becomes negative 5x equals negative 15. We're now at the final step to solve this equation, and all we have to do is get an expression like x equals 12. And to do this, we have to divide the left side of the equation by negative 5, and also the right side by negative 5. And the equation solves to be x equals 3. Equations with one variable can have one solution, but they can also have infinitely many solutions and no solution. Let's look at this through two examples. Question states, solve for x when x plus 5 plus 2x equals 3x plus 5. Since there's two x terms on the left, we can combine them to get 3x. And now we're going to move the 3x on the right to the left. So we subtract 3x on both sides. And when we do this, both 3x's on both sides cancel out. And we're left with 5 equals 5. This means that there are an infinite number of solutions because 5 equals 5 is true and there's no variable on either side of the equation to make it false. However, if we had an equation like x plus 2 plus 2x equals 3x plus 5, and when you solve this, you would get 3x plus 2 equals 3x plus 5, and when you subtract 3x on both sides, you get 2 equals 5. This equation would solve to be, would not have any solutions, because 2 does not equal to 5 in any case. The problem states to solve for x when ax plus bx plus cx equals 1. This is an example of a linear equation with unknown coefficients. This may look like a complicated problem to solve, but it's actually really simple. The equation is set up so that all the x terms are on the left side of the equation. So the first step to do in these types of questions is to factor out the x, because the x is a common factor for all the terms on the left side. When you factor out the x, you get x times a plus b plus c equals 1. And at this point, it's just a matter of isolating the x by dividing both sides by a plus b plus c. When you do this, the equation solves to be x equals 1 over a plus b plus c. Multi-step inequalities are inequalities that require multiple steps to solve. An example of this would be 7x plus 4 is greater than 3x plus 6. To solve this, we have three things to do. First, we have to move the 3x to the left side. And when we do this, we get 4x plus 4 is greater than 6. Now we have to move the 4 to the right side, and to do this we have to subtract 4 on both sides, and we get 4x is greater than 2. Now to solve this, we have to, the final step is to divide both sides by 4 to leave only an x on the left side, and our equation solves to be, inequality solves to be x is greater than 1/2. A compound inequality is a sentence with two inequalities joined by and or or. We'll look at what it means to be joined by and or through an example. The question says to solve for x when 3x plus 4 is greater than 19 and 2x minus 7 is greater than 15. You first have to treat these two inequalities as unrelated and solve each of them. The first step to solving the inequality 3x plus 4 is greater than 19 is to subtract 4 on both sides, and you get 3x is greater than 15. The final step is to divide both sides by 3 to get x is greater than 5. For 2x minus 7 is greater than 15, you have to add 7 to both sides, and you get 2x is greater than 22. Final step is to divide by 2 on both sides, and the inequality solves to be x is greater than 11. Now that we have solved these two inequalities, our next step is to graph them on a number line. Both of them will have an open circle because they are greater than. The first inequality will be shaded yellow, and the second will be shaded orange. This is where the word and becomes important. If the two inequalities are joined by and, then we have to look at the part of the graph where there is an overlap between x is greater than 5 and x is greater than 11. This means an overlap between the yellow and orange. The answer for this equation would be x is greater than 11 because from this point onwards, there's an overlap between orange and yellow. If the two inequalities were connected by or, then the solution would be would not be an intersection between the two inequalities. Instead, the answer would be x is greater than 5 because from that point on, at least one of the inequalities is true.